In this video, I want to talk about the complement and its probability. The complement of an event A is all of the outcomes in the sample space that are not already in A. And it's denoted by A prime. It's essentially everything else. So let's look at some examples of this. Let's suppose our sample space is days of the week. I want to know what is the complement of days of the week that begin with T. Well, I would want the opposite of that, so the days that don't begin with T. So we would have Monday, Tuesday starts with T, Wednesday, Thursday starts with T, Friday, Saturday, and Sunday. So these would be the days of the week that do not begin with T, or the complement of those that do. Let's let our sample space be rolling a die. What is the complement of rolling a 5 or a 6? So I want everything else I could possibly roll. A 1, a 2, a 3, and a 4. Now that I have the idea of complements, I want to talk about their probability. The probability of the complement is 1 minus the probability of A. Another way to say this is the probability of A plus the probability of its complement is equal to 1, which should make sense because every single possible outcome will either be in A or not in A. So together, they should comprise everything. Let's do some examples of calculating this probability. You roll a die. What is the probability of not rolling a 5? We may be pretty confident to say that this is 5 out of 6 since there are 5 sides of the dice that are not a 5. But let's think it through with probability of complements. The probability of not a 5 should be equal to 1 minus the probability of rolling a 5. Well, we know there's one side of the dice that has a 5 out of 6 sides. So that gives us 5 out of 6, exactly what we think it should be. You roll a die. What is the probability of rolling a number that is not a factor of 6? For this one, we might want to think through the actual factors of 6. Well, these are numbers that divide into 6 evenly, so 1, 2, 3, and 6. We may be able to look at this and realize that the things that are not factors of 6 would be 4 and 5, so there's a 2 out of 6 chance. However, let's think it through with probability and complements. The probability that it's not a factor of 6 is equal to 1 minus the probability that it is a factor of 6. We know there are 4 factors of 6 since we listed them out of a total of 6 sides. So we get 2 over 6, exactly what we expect it to be. Both of these examples, we could have figured out the probability without thinking through the complements. Let's look at one where doing the complement makes a lot more sense and is a lot quicker and easier than to think it out in a different way. Let's suppose you roll 2 dice. What is the probability that the scores are different? We could think through all the possibilities. We could roll a 1 and a 1, a 1 and a 2, etc., all the way up to a 1 and a 6. We could do a 2 and a 1, a 2 and a 2, etc. I'm not going to list all of these out, but we do have a lot of them. And we would have to sit here and list all of these out and then count all of the ones where the 2 numbers are different. Or we could think this through with complements. The probability of them being different is 1 minus the probability that they're not different or that they're the same. Well, we know there are 6 sides of a dice. We know there are 6 ways to roll doubles. Double 1, double 2, double 3, double 4, double 5, or double 6. And there are 36 ways to roll 2 dice. So this probability will be 30 out of 36.